Hi guys, so today we are given the problem, determine the magnitude of the resultant force acting on the screw eye and its direction measured clockwise from the x-axis. So first let's start out with figuring out what the problem is actually asking us for. First recognize that it's asking for the magnitude of the resultant force. This is the magnitude of the resultant force. We can write it as this. And we're asked for its direction measured clockwise from the x-axis. So when a problem is asking for its direction measured clockwise from the x-axis, then it's asking for, if you picture the resultant force or the addition of these two forces, it's asking for the angle that it's from the x-axis. So this can just be written as another theta. So we were given and asked for both of these, the magnitude of the resultant force and its direction measured clockwise from the x-axis. So first, let's start out with finding each of the force vectors to add them up to find the resultant force vector and then to find the magnitude of the force. So first I'm going to start out with creating a force vector for the 2 kilonewton force. So this 2 kilonewton force, if you want to find it and put it into a vector form or an I hat j hat vector form, you're going to first want to create a right triangle. So if you create a right triangle out of this force, you have your 45-degree angle right here, and you have the 2 kilonewton force coming out right here. So how you do this is you use the cosine and sine right triangle identities to put this in vector form. So recall that the I hat component is the x component of a force vector. So the I hat component would be 2 cosine of 45 in the I hat direction. And recall the j hat component is the y component is going negative. So it is negative 2 sine of 45 in the j hat because it's opposite from the angle. Next, let's move on to the 6 kilonewton force. Now, the 6 kilonewton force also can be pictured as a right angle. It's going negative in the x direction, therefore it's a negative 6 cosine of 60 in the I hat direction, and it's going negative in the y direction as well, therefore it's a negative 6 sine of 60 in the j hat direction. Now to find the resultant force of these two vectors, then you just have to add both of these vectors up. After you're done crunching the numbers into your calculators with all the cosines and sines, you should be ending up that the force resultant, that is vector, is a negative 1.59 in the I hat and a minus 6.61 in the j hat. However, now you still don't have the magnitude of the resultant force. To do this, it's very simple. All you have to do to find this magnitude of the resultant force is to put both of these numbers into square root, square them, and add them up. So I'm going to put this negative 1.59, square it, add it with this negative 6.61 squared. After you're done plugging these numbers into your calculator, you should be ending up with around 6.67 here, so sorry, 6.799 kilonewtons. And that is your final answer for the magnitude of the resultant force. Next, let's move on to the direction measured clockwise from the x-axis. So when we're trying to find this, recall that if you look at this resultant force I drew, it can also make another right triangle. And this right here is the I hat component because it's the x component. And this right here is the j hat component because it's the y component. So you use the I hat and J hat components that we found from the resultant force and use the right triangle identities to find this theta. So recall that tangent is opposite over adjacent, which in this case it is y over x, otherwise known as our I hat and j hat components. So for this one, we'll be using that tangent of theta is actually the equal to the negative 6.61 over a negative 1.59. Now afterwards, what you're going to want to do is you want to move the tangent over. So therefore, theta is equal to the inverse tangent of these two numbers, that negative 6.61 and the negative 1.59. Afterwards, all you have to do is plug these two numbers into your calculator, and you should be getting a 76.5. However, if you look at this where I drew that right angle, this is the theta I came out with. I came out with it being counterclockwise rather than clockwise like how the problem asked for us. However, to figure this out in the clockwise form, it's very simple. All you have to do to switch is just subtract that 76.5 degrees from 180 degrees. So once you do that, you should be ending up with 103.5. Therefore, you have your final answer for the theta and the final answer for your magnitude of the resultant force. Thank you and have a great day.